So now that we've looked at atoms and we've seen what makes up atoms, we're going to look at how we got from this whole idea of there's some kind of a mass ratio going on to, well, this is an atom, this is what's inside the atom. And then this is going to be covered in more detail also in chapter 3 when we look at the electrons and what the electrons are doing. So I know some people love chasing down rabbit trails and finding cool stuff. These 3 explanations are given by Tyler DeWitt. Well, he's actually got more in here now than he used to. But these explanations are great explanations of these experiments because it's kind of hard to understand what's going on in an experiment when you read back to these experiments that happened over 100 years ago. So I really do recommend looking at those if you want, but it's not going to be tested or anything like that. It's just really interesting how the experiments worked. So what we came up with was that in 1896, and notice the time frame here, 1896, so it was back in 1807 when Dalton came up with this, and then almost, like 100 years later, Thomson is playing around with a cathode ray tube, and he figures out that there's something negative in the atom. And he figures out that he can mess with he can figure out a specific charge mass ratio. He's basically taking something that's like a magnet and putting it towards these cathode ray tubes that have a very, very small concentration and of atoms in them, like tiny. And he's noticing that they are going away from the positive pole of the magnet and towards the negative pole is kind of what he's figuring out. So anyways, he's the guy who figured out, hey, there is something negative, which we will eventually come to call these electrons. But he couldn't quite figure out everything about it, and so it took another 10 years before Millikan figured out how to work out the charge, and this was a really elegant experiment that he did. And once he figured out the charge, then they could put in, and they figured out the mass of the electron. And so he figured out the amount of charge on electrons. So that's the electrons. What about the nucleus? Well, at the same time, we have Rutherford, and he's looking at the inside, and he was doing some experiments, and he figured out that most of the space inside the atom is empty, but every once in a while he would hit something that was so strong that it would knock this ray he was sending through the atom back at himself. And he figured out that whatever it was that was knocking that ray back, he figured out that it was positive. And so he figured out that the nucleus was positive, but it's really that also that he was talking about protons. And then look how much longer it was before Chadwick came along and he was like, hey, something isn't right with this atom because we're getting way different masses if it only has protons on it. And so he did all this work and he said, we need another particle. We know it's not outside where the electrons are, so it must be inside. And that proton, he was doing some work with blocks of wax, of all things. And that's when he realized that there were such a things as neutral things in there, and he called them neutrons. So this is our atom. This is a really classic picture, and it is not really correct. But that is a great picture just emphasizing protons, neutrons are in the nucleus, and the electrons are on the outside. Also, this is a great simulation. Bring it up over here. Where you can just throw things up there. And you'll notice, like, you try to put the proton on the outside, it won't go. But it will go up on there. See, also, it will not go in the nucleus. And also, it only goes on the innermost part of the atom. Then when I add it, if I try to add another electron, here, he won't go there. So this is also letting you guys know that the electrons are actually going in certain places. We're going to come back to the simulation when we're looking at how protons and neutrons and electrons affect charges on atoms and ions. But it's a great simulation. You can play around with it. And you can try it with 4 of each particle. See which atom it is because it'll tell you on the chart which one you have. And you can also try removing each type. So what is the scale? And I have a really nice video in the extra YouTubes But if you go and you put something on the center yard line, I can't really even see the center yard line in here. Is it like right in there? If you put a blueberry in the center yard line, and then if you took this football field and you made it 3D so that it went all the way above and all the way below, the blueberry is the size of the nucleus. And this outside area, there is going to be an electron or 2 electrons flying around in all of that space away from that itty-bitty blueberry of nucleus. And yet it's fascinating because the nucleus is so strong that it can pull on those electrons, and it keeps the electrons basically in the stadium. The electrons don't leave the stadium. They're completely attracted to that teeny tiny positive charge. So this nuclear pull, it's more attracted to that nucleus than it is to gravity or anything else. This pull between these two is huge. So where's the mass of the atom? You want to say the mass of the atom is in the nucleus. Where's the majority of the space? Outside the nucleus. And your nucleus is positive because that's where the protons are.